Okay, well, let's look now at the processes 8.2 and 8.3 in project control, or project quality management knowledge area, rather. Perform quality assurance and control quality, the two that are circled here. Again, just for your edification, to remind you that this is important that you know these things, especially since there are not depicted in your PM project management guide, are the planning, executing, and monitoring and controlling process groups that these activities are members of. So remember, monitoring and controlling, you're going to monitor the deliverables based on the metrics that are provided from your plan. You can monitor the metrics and you can control the results by issuing change requests, etc. And then you're going to send deviations over to control or quality assurance, and they're going to deal with getting you back in line. So let's see how that works. So quality assurance. Now again, we could have done this the other way, done 3 first, but we're just going to do it in the order that PMBOK provides. So just remember, one goes before the other in the real world. But performing quality assurance, what is that? It's the process of auditing the quality requirements that are provided in the plan, and the result of the measurements that are done in 8.3 in your monitoring and control quality is taking the quality requirements, auditing them against the actual measurements against a deliverable or a process in order to facilitate improvements to the quality process. That's why it's a doing thing. You're going to be improving quality processes because of whatever happens with your metric deviations in 8.3. So what comes in here, certain project documents, we'll see your plan, of course, has your metrics in it with the process improvement plan that you're going to deal with in this process. The actual metrics you're going to measure against. Now from 8.3, this is where the deliverables come in. Remember, deliverable comes in directly, the raw deliverable right out of execute work. 4.3 comes in. You do your measurements, and then the actual quality control measurements are outputs, and they are inputs to this process. Okay, within this process, you're going to do some black box stuff, but it'll become white box here in a minute. We'll know what that's all about. And the result is, the primary result are change requests to make improvements, particularly to your processes or also to your process improvement plan. So, and that would be the project management plan update, by the way. The process improvement plan is just a component of that. Other adjustments come from change requests. So the input quality management plan, this is your approach for quality assurance in your quality process improvement. And what's not shown here is the actual metrics that you measure against are in there, although they're broken out specifically coming up. Your process improvement plan is supported by your quality assurance activities here to update your plan. It'll be updated, even though it's input here, it'll be adjusted if needed and then re-input later. Quality metrics, these are the attributes you're going to measure, and the deviations that you're allowed, your tolerances, your grades, your quality, whatever it is, they're coming in, and they are part of your quality management plan. Your quality control measurements come in. These are the actual results of 8.3 measuring the process or the deliverable that comes in from your work products, and they're used to analyze quality processes against your standards. Project documents that come in, you may have some system configuration management documents that you also use to help you apply metrics to and look for deviations and things like that. Now you have these things coming in particular the actual measurements that you've taken. Tools and techniques now are how you deal with these things to produce your desired outputs. Here are some tools. Affinity diagrams, process decision flow charts or program charts, interrelationship diagraphs sound kind of foreign, but we'll see what these look like. Tree diagrams, prioritization matrices, activity network diagrams, matrix diagrams. Quality engineers deal with these day to day. They're commonplace for them. They can spout off definitions and how these things work like crazy. You as project manager don't necessarily need to understand the detail of how these things operate. You just need to know that they exist, that they apply to this particular process, and what their basic function and benefit is to use them on your project. Rather than actually sit down and make them work and create them, you just need to know, what are they and why are they a benefit to you under quality. So here they are. They just happens incidentally to be these 7 of them, different than your 7 quality tools, right? So affinity diagrams, here's a subject and here's things that apply to them. Here's another part of a deliverable or something or a quality issue. Here's stuff that is affinity or relates to them most. You need to, if you're really interested in this, look in more detail in the PMBOK, go out and research these things. if you want to use them on your project, because even the PMBOK doesn't help you actually use and apply these things. What they're telling you is these are the best tools available to help you with quality in your project if you decide to adopt them. So it's up to you as a project manager to go out and figure out, do you need to use them, and then find a resource on your project or in your organization, or get a third party to do this for you, to apply these tools so that you have better products and better processes. But for the PMP exam, which is our real focus here, is you just need to know that these exist and basically how they can benefit you. So these are quality management and control tools. PDPC, here's a diagraph, sort of like a mind mappy kind of thing, but it's a system flow diagram, what relates to what. And you may find a process here that's always broken right here. Well, why is that? You need to fix it. It could be that kind of thing. Tree diagrams, this spawns that, this spawns this, or like the decision tree diagram, although there's no metrics involved, no money involved. That is quality metrics you're looking at. You can prioritize things using the tree diagram. It looks like you can prioritize them. Network diagrams with dependencies and all that, matrix diagrams. All of these, again, if you need something like this, go out and research it. But you need to know for the exam that they exist, what the names are, and whether you need to look at them further and apply them to your project. Now, quality audits is a tool technique. You need to make sure that all the project activities you are doing comply with your plan. That's why you have a quality plan, so that you can comply with it, so you can produce quality work in your processes or in your deliverables. And quality audits confirm that the implementation of approved change requests have been implemented properly. Quality. Because you're building something, now you have a change request, it's approved. You need to make sure the essence of that change request gets embedded in your work. So quality will audit that to make sure that happens. Process analysis, another tool. Your process improvement plan is implemented here, and you focus on root cause analysis. Remember, if you get rid of root causes, many problems disappear because they're all stem from one source. And your process improvement plan may go after that root cause, either mitigate it or eliminate it, so that your processes are much more capable, stable, within tolerances and the whole bit. So process analysis of how you do things, improve that, and your quality will go up. So those are your tools. And the outputs, the prime output of quality assurance now, after you've measured and come up with deviations and gone through your analyses to see how you can improve your processes with all those various tools you have at hand, are change requests. Big enchilada, again, here's another big enchilada, the change request for quality, for preventing something to happen that you see is coming out of control. You're trending, you may get control. Remember the control charts where you're measuring, let's say you need to build a number of things, and today, and here's your baseline. It's right on the baseline. Here's a little up, here's a little down. Okay, well, you have your upper and lower control limits. Once it goes beyond an upper or beyond a lower, that's a real red flag. And if you see that coming, and with control charts, it may be more difficult to see, but sometimes you see the things going like this. And pretty soon they're going to hit this. You need to do something to prevent that from happening. Because even though if you're doing multiple outputs, deliverables, if one is out of whack and you trash it, of course you're wasting some money and time on it. But you can then, likely bring it back under control easily because everything else was. It could have been just a bad product, a glitch in your assembly line, some crazy thing. Somebody's sick that day, they don't feel good, and they just are sloppy, so you get one bad outlier. The thing is that when you get 7 of these things in a row out of control, then you got a real problem, and it's going to persist perhaps, and then you need to take corrective action. So prevent it before it happens, fix it with corrective after it happens, and you'd rather have, again, prevention over correction or inspection. Your output, your project management plan, and any of its subsidiary plans may be updated because you're adjusting quality, so some of those plans may be refined so that you can provide better quality. Scope, quality management plan, your scope management plan, scope baseline, your schedule deadline, or your schedule plan, your cost, all those management plans may be affected as you adjust and improve the quality posture of your processes and your deliverables and your project in general. Project documents that could be updated, again, it's very similar. Your quality audits, your quality audit files will get updated with the results of what you're doing. You may need training plans now. You may find the need for improved or to start training in quality so your people know why they're doing something, why they need to be consistent and follow, their work processes properly, and how to try to avoid doing sloppy work so that the defects are minimized and everything's in tolerance when they're doing their work. So training plans could also be updated as part of project documents. And of course your process documentation itself on instructions on how to do things may change to make adjustments. You may issue a change request for preventative action to adjust your work instructions, very appropriate. So those kind of things. Organizational process assets, your quality standards, may be adjusted because of the work you're doing. And of course, the quality management system, if you have such a system that assists you in doing this, may be updated in some manner. But the big one is change requests. They go out for corrective or preventative action. Okay, when we come back here in a minute, now we're going to talk about 8.3 quality control, which is where your raw deliverable comes in and where you then apply your metrics to it to find deviations and that sort of thing. So we'll be back in a minute. Okay, well, we're back and we're going to look at the third and last process of project quality management knowledge area, which happens to be 8.3, control quality. Now remember, in the scheme of things, as you're producing your deliverables, they would come into this process first. You'd measure them according to the metrics that you are prescribing in the quality management plan, and then the deviations, or even just the entire results, good or bad, of these metric measurements would go into 8.2, where they would be reviewed and appropriate actions taken to bring quality control back on track and improve quality in your quality control your quality improvement plan and things like that. So we've already done that. Now we're going to go and look at the actual measuring of items. So this is called control quality. Okay, so quality control or control quality is the process of monitoring and recording the results of executing the quality activities in order to assess the performance and make necessary changes. Now, assess performance could be assess performance of your project processes, if that's what they're looking at, or generally, from your point of view, mostly it's assessing the quality of the deliverables that you are producing, and then make necessary changes, in which the changes would be made here, and then ongoing further changes in your quality plan and process improvement plan will be made in 8.2. So here, operational techniques and tasks that come to bear under here. You're going to deliver, or to verify the deliverable meets a quality requirement specific to that deliverable or to that work item. Quality assurance is planning, executing, and providing the confidence that the stakeholders' requirements are met. And again, these are stakeholder requirements. You and your team are not making up requirements because you think they're good. You may do that, but you need to then vet them through the stakeholder because it is their requirements, their attitude on risk and quality that you need to satisfy because it is their project and their deliverables and results are there for them. And it might be that for your stakeholder in-house, your sponsor, they may be representing a third party that will go through them to deliver elsewhere. So either way, it's your sponsor, your main stakeholder that needs to be totally satisfied. Quality control, where we are now. Let me just go back there and clarify that. Quality assurance, I should have put this on here. This is 8.2 that we just talked about. That is where you plan and execute and provide confidence by your improvement plans. Now we're in quality control where we execute the quality metrics we measure. We formally demonstrate that the acceptance criteria or metric has been met. And you do that using reliable data, which are your metrics that come from the plan. Statistical control process terms. You need to know, again, they're kind of intuitive, but make sure you know these in case they give you different kinds of definitions in the PMP exam. They could be messing with words and trying to mess with your mind, so make sure you know exactly what these are. Prevention, keeping errors out of the process by some method, however you're going to do it on your project. Inspection is keeping errors out of the customer's hands. So prevention, keeping it out of the process so that you don't have to see it in inspection, and inspection as you find it, fix it so it doesn't get in the customer. And again, the worst case scenario under cost of quality is to deliver it to the client and have them find a defect. The worst thing. So certainly prevention over inspection. That's what they're talking about. Keep errors out of the process first. And if there are errors, keep them out of the customer's hands. Attribute sampling and variable sampling are another set of terms you need to know. And they're out of PMBOK, of course. Attribute sampling, results that either conform or they don't conform. Some attribute you're testing, it conforms to your metric or your benchmark, whatever you're using, or it doesn't conform. Variable sampling measures the degree that it doesn't conform. How badly does it not conform? And there's a tolerance there probably that you need to consider. The third one are actual tolerances and control limits. Tolerances, are plus or minus this. There are a range of acceptable results around a midpoint of some sort, tolerance. Maybe not even a midpoint. It could go from 0 up to some positive number. And the control limits are boundaries of validation in a stable process, like a control chart. Remember, you got your preferred result here, and you plot over time, and you got your upper and lower bounds, and if it goes above or below the lower bound, then you're out of control. If it's on this line or right within the line and within the boundaries, upper and lower, then you have a stable process. Even though there's variation, but depending on how close or far those upper and control limits are to the middle, you're still have a stable process. So, This just, the point here is to clarify your key quality control inputs are your metrics that you're going to measure against. You have checklists that help you do those metrics so you're consistent and you catch everything, you don't miss something. Work performance data comes in where you can do some charts to see how you're out of control, your control charts, all that. Approved change requests come in too to control quality, so you can make sure that those things are have been addressed properly. And obviously your deliverables now, as we all know way from the beginning, from the life cycle of a deliverable, once they're built, they, as a quote, deliverable, unquote, just that word, come in here as inputs ready to be assessed. Here's your quality control methods. Here's our 7 basic quality controls tools again that we saw before. Same thing here. You can use the same set of stuff to do your diagrams and whatever it is you need so that you can analyze the quality profile of whatever you're looking at to make sure you're within tolerances and all that. Statistical sampling, of course, inspection is the most prevalent method, although inspection itself may not be appropriate for some things. You may have to do other methods, but you need to, one of these things will help you assess the quality. And approved change request reviews. So approved change requests come in as inputs. Now there's a technique where you review them to make sure that they're addressed. And your outputs, the key outputs are the actual, number one, the actual quality control measurements that you've taken against your incoming metrics. Okay. If your deliverable is within tolerances of what you measure, then you can promote it to a validated change. A verified deliverable. I've verified that this deliverable meets our quality control requirements, which is good. And as we should know by now, the next step with that deliverable downstream is this deliverable actually what the client wanted? Scope control. And if it had good scope control, then yes, that is what they wanted. You will output work performance information from the data that comes in. You can provide a lot of specialized information downstream to your deliverables building, direct and manage the work, execute the work, and of course change requests are an obvious output to make corrective or preventative action. This is your data flow diagram for control quality, and what I've done here is not just to play around with colored pencils, but to outline the major inputs that we saw on the prior screen, just to show how where they are, where they come from, how they flow in, a little different look at it. And your major outputs are over here. Not that these other inputs and outputs are less important, but these are the ones that are fundamental to performing this activity. And all the stars up here, see, integrated change control, all of these have a linkage back to or into integrated change control in some aspect, just to show how pervasive, again, integration is, just by the nature of the definition of integration, how all these processes are integrated together through the 4.0 project integration management knowledge area. So inputs, your project management plan, how quality assurance, how quality management in general is performed, your quality metrics, your project, and most likely your product or deliverable attributes that you're going to be measuring, how you're going to measure it, and you can come up with things like function points they just mentioned specifically in the PMBOK, mean time before failure, mean time to recover, all these kind of things could be valuable to you if it applies to your project. Quality check lists. Now these aren't check sheets. Check lists and check sheets are both within the domain of quality management knowledge area, but check sheets help you tally results, and check lists are make sure you look at these things. They're a little different, but they're only mentioned twice in the PMBOK, well, a couple of times, but specifically referenced, like look in the index, twice, and they're both within quality management. So you should look those up, make sure you understand why they apply and where they apply. But basically, it's to ensure that specific deliverables have met requirements. Checklist has done this, this, and this. And a tally sheet is kind of a side thing. It appears where you just you log results, and then over here on your checklist, you say, yes, I've logged those results. Strange with the words, but it's important you understand the difference in case PMI is devious enough to try and test your knowledge on this minute but perhaps important detail. Work performance data comes in, and that would be data like planned data per your baseline plan. You would compare that to actual results, whether it's schedule, cost, time, whatever it might be, technical performance, schedule performance, cost performance. You have that data comes in from executing the work. Approved change requests, again, come in because what you're going to do is validate that those are right, that they've been accomplished and embedded in the work product. The change log, which shows all the status of all changes, it cites the approved, unapproved change requests. Defect repairs, revised work methods, revising the schedule could all be under the umbrella of an approved change request. I mentioned this before, timely implementation must be validated, not verified, but validated, which means was this approved change request embedded in the work in time to make a real difference? It could be you're doing your work and an approved change request comes in, but it didn't get over to the work area in time, and they went on building, and now they got to back up and do some repair, rework. So timeliness of change requests, once they are approved, is critical to quality. Of course, your deliverables come in. That's the main player here. Your raw deliverables, they will be validated as built, constructed, whatever, performed correctly. And this is the only input here out of all the 47 processes where deliverables are an input. Organizational process assets, whoops, there. Project documents, that is. Quality audit reports, your training plans, again, if you need to make corrections and improve your training, your skills of your people with training plans. Quality tools that you use, documentation on them, project documents come in to help you do your work here. And process assets such as issues and defect reporting procedures, work guidelines. Work guidelines, of course, is obvious. You may want to look at those to see how your organization expects people to operate under certain conditions, and maybe there are adjustments to that you need to make. So those are all tools or inputs you have to help you control your quality. So that's your inputs. So when we come back, we'll talk about the tools and techniques available to produce your outputs. Okay, so here's quality control again. We have our inputs, primarily our deliverable and not to be diminished by any manner, approved change requests, amongst a few other things. Now here's our tools and techniques that are recommended by PMI and in the PMBOK methodology that we can use to our advantage to take those inputs and assess the quality of our products that we're producing, or our project processes too. So here we have the 7 basic quality tools again, that if this is appropriate for your project, and it may be appropriate in certain parts of your project against certain deliverables, you may want to use them if it's appropriate. The same thing, your cause and effect diagram. And if I was a PMP question to you, I'd say, what other names do you call cause and effect diagrams? Well, one of the options would be Ishikawa, or a fishbone. So you need to know that those 3 are equivalent. Flowcharts, again, in particular, the SIPOC was called out specifically, so it must be important. I'll bet there's probably a question on that. And all the other kinds of flowcharts that you may use to assess where quality is a problem. And because now you're going to be measuring things, so you may have to have flowcharts specifically maybe on how you do your work to build deliverables. Here's the flowchart on how you build these complex deliverables. You look at that, you test things, you inspect, you say, did they do this, 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 and this? You have a checklist here, check sheet, or checklist. It says follow the process, make sure they're doing it. You may have to observe, inspect, observe what they're doing it. You have your check sheet over here where you can say, oh, they did this, they didn't really do that right. Go back to your check list, back and forth, and then you get your results in the end if you're looking at a process via a flowchart. And your checklists, again, like I mentioned, that's what it is you inspect. Check sheet is the results of your inspection, basically. A Pareto diagram, again, is the diagram that loads up in the front the most common problems toward the least problems of a particular process. You can determine what you need to address first. Histograms, again, they aggregate into the middle, the most common stuff. Control charts and scatter diagrams. So the same thing, go look them up again. But you have the same tools available here to assess the actual inspection of or quality of the incoming deliverables. Statistical sampling, again, is not the entire population of everything. If it's appropriate and you have repeatable things that you're doing and building, you don't have to look at every one of the results. You can look at a good sampling of them. And your organizational process assets may have guidelines on how to do that. Otherwise, you can look on the web or wherever for best practices and what your sampling population should be based on what you're doing. But whatever, it just means you don't have to look at everything, and you log, obviously, your metrics. Inspection's the bigger one, the most common thing that you would do to inspect your processes and deliverables. Physical examination of the work at any stage. That means, here's the final product. You inspect it and stuff, but what's inside the product? If it's code, here's your code, here it is, you see it operating. What about each module? You want to know along the way how these things, what the quality is along the way. So you look at your detailed work breakdown structure and all the discrete work activities. You may want to get down to that level and look just how that 2-hour piece was built. Very common in an agile environment, for example, because they really atomize their thing for quick turnover. So you're really going to look at quality very frequently. So anyway, at any stage, you look at quality. Review You do your own reviews, peer reviews, audits, walkthroughs, say of code, but inspection is the most common, and you can validate that defect repairs were made also by inspecting, which is one of the tools and techniques that are coming up right here. And here it is. Again, an input to this process is our approved change request, and the purpose again is to make sure, for quality standpoint, that these approved change requests made it into the work environment and were incorporated into the work in a timely manner, so you don't have to back up and say, well, I should have gave this to you 2 days ago, sorry, redo this piece. You got to be timely. So the review here is just to do that, verify that it was implemented as approved. Now those were your tools. So here's your outputs. Your actual quality control measurements are here. Documented results of the quality control activities. You know, pass, 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 fail, you know, whatever it might be, these are your measurements. And they're passed on to 8.2 so they can deal with the good and the bad there. Validated changes come in here. These are changes that were verified. You got to watch out with these words. I mean, I'm just speaking normal language now when I say verified. But these are changes that were confirmed to be incorporated in the work. Changed, repaired work was inspected. It was accepted if the change is good. It's called validated. Or it was rejected if it was too late or wasn't done right. And possible rework if it wasn't done at all, for example, or done wrong. So validated changes is an output. Or verified deliverables. Yeah, validated changes. Here's your verified deliverables. Again, verified means that, yes, it was built according to our specs. It met all of our metrics, whatever might have been applied here. It was met them, was within tolerance. We're happy with it. We don't mind giving this now to the client, to our customer. But before you do that, and the customer says, well, that's nice, but that isn't really what I wanted, it goes through scope control that we saw a couple modules ago, and way in the beginning too, in the life cycle of this deliverable, that then there's the chance that you validate to make sure that this is actually the item that the client wanted. Hopefully it is. Work performance information now is output by you during this process. Your performance data and all the stuff with metrics is collected, is analyzed in the context of quality and of deliverable you're looking at. And any causes of rejections because of bad quality, rework, defects, or process adjustments in the way you build things, your work processes, are information now that are actionable, and they're pumped out into the appropriate inputs so that it can be responded to accordingly. Change requests, of course, recommended corrective action, defect repair if it's that bad. Corrective action could go with a defect repair. This is defective, fix it, change request, and it could be also another change request. Well, we need to correct this process so we don't get this defect again. And preventative actions could be other types of change requests too. So all these come out of your quality control. PM plan may be updated, your quality plan may be updated itself, subsidiary plan, and of course your process improvement plan is a very likely candidate for update as you try and keep things, make things better, reduce rework, reduce your cost of quality, and all that is good stuff to do. Project documents that may be affected by your controlling your quality. Your standards may be updated in some respect. Agreements, stuff you've purchased outside, you may need to make some change request to those vendors and sellers and the way they're, or what you expect from them as far as quality. You may increase their quality needs or just make adjustments in general. So don't overlook agreements, what you have coming in later, because even though you're not building it, you're still responsible for the quality of what does come in that you bought. So you need to work with your sellers to make sure they give you quality goods and services. Your audit reports that are a fallout of this get filed as project documents. Training plans to improve the work methods of your people are project documents that may need to be updated. Assessments of effectiveness of all these plans and metrics. You may issue reports like this, they're project documents, as well as your quality tool process documentation. All these charts we saw, all the statistical analysis, tools and techniques, you may want to document those and change how you use them somehow so the next person can use them better. Organizational process assets, the completed checklists, of course you're going to want to keep on file for reference in the future, and lessons learned throughout all this process. You're going to want to keep track of it for future people to the benefit of their project and your organization. So guess what? That's it for quality management knowledge area. I think you can see how important it is to have good quality control and management on your project. To have quality management at all on your project is incredibly important, along with risk. And those two things are overlooked many times. And I think you can see the fallout of not doing these things as far as you being successful as a project manager and delivering a successful project. So now what we're going to do is get into the actual nitty-gritty of actually scheduling out, costing out, and finally, delivering that deliverable. So next we're going to talk about time management. We're going to plan, define, and sequence project activities at the WBS work item level. Way down there, we're going to start planning those and sequencing those so that we can start building them according to a schedule finally. So we're going to do that in Module 18.